Okay, so welcome to the third week of course Open Run, the future of radio access network. Hi there, I'm Roger Machas and I'm a course creator for the Asia Open Run Academy. So this online course is a collaborative effort of DICT and Asia Open Run Academy, and it is made possible by the American people's support through the United States Agency for International Development, or USAID. So today two of Asia Open Run Academy's most distinguished lecturers will each cover one of the two topics. So sa ating first session, which will run from 8 a.m. to 10 a.m., we will delve deeply into RAN Intelligent Controller. This will be delivered by Josel Reyes. And in the second half, we have a visitor from Telcom University, which will show um, how to access the Open Run remote lab in Bandung, Indonesia. Okay? And sabi ko nga, we had a very busy week last week. And last week, meron tayong major event sa mga ECE. So this was the ICEP AGM 2022. So I hope kung isa kayo sa mga nakasama dyan, or is either face-to-face or online. So during the 15th day of the November 2022, one of the highlights in the technical session is the introduction of Asia Open Run Academy in the ICEP AGM 2022 held at the PICC, or Philippine International Convention Center sa Pasay City, and where we showcase and discuss the Open Run access, which includes the introduction to Open Run solutions, split options, RAN architecture, open systems and hardware, RAN ecosystem, and deployment trials. So ICEP celebrates its 72nd year of being world-class organization of humane, competent, virtuous, and globally competitive electronics professionals. Okay, so we are now on the third session ng ating course for this week. So mamaya yung ating second half, meron tayong remote access as I mentioned before. So I will be sharing to you the remote access. So meron lang tayong 7 approved registrants, no? So first come first serve lang tayo dito. Although I sent an email early this morning para magkaroon kayo ng access. I'm not sure if somebody has tried to access yung Google form. But now I'm sharing the Google form sa remote lab, and then we'll get an approval. So the first 7 registrants lang yung makakapasok, because if we give you all access right now, baka mag-congest yung ating VPN. So limited lang yung ating VPN access. So the first 7 lang yung makakapasok. But for the rest, of course, you can still watch and learn how we access the remote equipment in the Bandung, Indonesia, under Telcom University. Okay? And of course, before we start, para magkaroon kayo ng mga updates sa different activities, events of Asia Open Run Academy, you can visit the website at facebook.com/Asia ORAN Academy. And later on, just pardon me for giving you a lot of feedback form, no? And we'll have a separate form that I will sending now. So every now and then I will be sharing this form. So this is the USAID attendance form. So this is on top of the feedback form that is being requested by the ICT. So ito yung ating link ng USAID attendance. So if you just want to get an attendance for the USAID, it's para makuha lang natin yung inyong mga participation for today. Okay. So let me proceed now sa ating introduction ng speaker for today. Our speaker for today is she is a full-time academic staff at the Electronics Engineering, or ECE Department of University of Santo Tomas, Manila, Philippines. She is teaching several undergraduate courses on communications and computer networks. She is also a PhD candidate in the Department of Electronics and Information Engineering at Hong Kong Polytechnic University. Her current research is focused on IoT, wireless sensing, machine learning, and related topics. She is one of the Asia Open RAN course co-creators who developed the two courses, namely the deep dive into ORAN architecture and the RAN intelligent controller. So ladies and gentlemen, engineers, electronics engineers of the Philippines, please welcome Engineer Jocelyn Mariela Reyes.
Hi, hello, good morning.
Good morning, Jocelyn.
Hi. Share ko na lang din yung screen.
Yes.
Gusto ko yung medyo pa-suspense pa yung name ko. Kahit na last time, na-introduce na rin ako. Yan. So, ayun. Okay. You should see my screen now po. Tama po ba?
Yes.
Hindi ko pala kita yung chat.
Visible na siya.
Okay. Thank you. So, ako po ulit no, for today. And we'll be having this first half of the session no, more on the topic no, on the RAN intelligent controller or again, a radio access networks intelligent controller. So for the first half of this session, we'll just have a more in-depth discussion of the RAN intelligent controller. But before that, no, mag-discuss ako ulit ng mga natutunan natin from last meeting. No? Hopefully, yung parang repeat no, of those slides no, will help solidify yung knowledge natin no, in the ORAN architecture and this RAN intelligent controller. No? Okay, so this particular slides no, is part no, of the RAN intelligent controller course no, by Asia Open RAN Academy. This course covers RIC or RAN intelligent controller, the ORAN interfaces, and the functional splits. No? So this, all of these concepts were already introduced before no, last meeting, but we'll go over them more in detail no? And also para ma-refresh po tayo. No? Okay, so under this course, no, we'll have the following topics. We'll also have RAN control loops, non-real-time RIC architecture, and near real-time RIC architecture, as well as the X apps and R apps. Also, we'll have here the functional split options, which define how the functions of the control and distributed units are divided. So you may have already remember what is functional split. It was mentioned 2 weeks ago by Richard, and also I mentioned it last week. No? But today no, we'll go over this more in detail. Okay, so this course is actually best taken after completing the deep dive into ORAN architecture, since the ORAN architecture no, consists of several blocks, several interfaces. No? Upon looking at it first, no, it's of course it looks a little intimidating because there are a lot of connections. No? But over time, if you keep on being exposed to it, no, it makes it easier. No? So mamaya, i-test ko kayo yung memory nyo no, on the architecture as well. Okay, so anyway, after this course, so at the end of the course, the learner must be able to summarize the RAN intelligent controller and the functional split options, explain the difference between the X apps and R apps, and differentiate non-RT, RIC, or RIC, and near RT, RIC architecture. Okay, so this is the different sections of this course. And brief review of the ORAN architecture, no? Yung maraming blocks, maraming mga interfaces, no? And then let's have an overview of RIC and more detail on this, and also particularly yung functional split, saka ito mga specific topics pa no, under the RAN intelligent controller. No? Okay, so an overview again, no, or a review of the ORAN architecture. Okay, so again, what is radio access network or RAN? This RAN is part of the whole network of the cellular or the telco. The RAN is the part that gives access towards the user equipment. So the access network here is the one that is providing access to the user equipment through a wireless media or wireless mechanism or radio frequency. Okay, and this access network here is connected to the core network via the transport network or otherwise known as the backhaul. Okay, so the main focus of the Open RAN is this part, this access network here. And by making things open, or by making the hardware open, the interfaces open, this actually will translate to a cheaper or more cost-effective implementation. So if the deployment, if everything is more cost-effective, then it would be best for the mobile operators, and they can expand their coverage because it will be more cost-effective, and it's more economical, basically. Okay, so of course, now we are very much familiar with base stations. So the base stations are part of the access network or the radio access network. Okay, so previously, in the last meeting, we looked into the different names of this RAN. So the name of the RAN varies depending on the cellular technology or cellular generation considered. So we have for 2G, we have the GSM Edge RAN, so GERAN, and inside the GERAN is the base station controller and the base transceiver station. Then for 3G, we have UMTS, or Universal Mobile Terrestrial RAN. This is UTRAN. And under this, or inside this, is the RAN Intelligent Controller and the Node B. Okay, so this Node B is the part of the RAN that is upgraded later in the 4G. Kaya naging E-Node B siya. So the RAN for 4G is called as the Evolve UTRAN, or we can we can commonly see this E-Node B here when looking at documentations, when looking at the deployment scenarios of 4G, specifically in LTE or long-term evolution. And then now in 5G, we have the 5G RAN. It's easier to remember because you just have to add 5G RAN. 5G is new radio, and particularly the node is called as G node B. Okay, so as you can see, the terminology for RAN varies depending on the considered cellular technology generation, and RAN is the general name for the access network equipment for of cellular network. Okay, so you also look into the different evolution, or rather the evolution of the radio access network in terms of the implementation, whether it is a distributed RAN or a traditional RAN, wherein it can be like a split option or non-split option, wherein the baseband unit and the remote radio unit are all housed inside the single equipment or single cabinet. But there was a split option wherein the radio unit is placed nearer to the antenna to minimize the losses incurred in the transmission line here. So, and then since they are decoupled, it started the disaggregation of the radio access networks. Okay, so upon going to the cloud RAN or the centralized RAN is where the baseband units is pulled together in a separate, perhaps data center or central office. This baseband unit manages several different remote radio units. So this particular part can access or can manage several different radio access units or remote radio units. Okay, that way it's pooled, and you just have to have an optical distribution network to allow the connections. Okay, but that one is limited to areas wherein fiber optic connections are deployed. Okay, another type is the vRAN, the virtualized RAN. This is where things start to become open, but it's not yet open RAN. So the functions of the distributed unit and centralized unit are now virtualized, and they are separated. Basically, the hardware and software are disaggregated already. And finally, at the Open RAN or the ORAN, this is where the hardware is open, but also the interface is open. Originally, the interface was not open, So if you change your device, it must be compliant to the proprietary interface. Okay, so this time in ORAN, a mobile operator can now virtualize and disaggregate their own RAN, and it's open. Okay, so this is just the evolution. So we saw that traditional RAN has two options, whether the RRU and BBU are co-located or not. And if they are split, they are connected by this proprietary protocol called the CPRI. Okay, and then the centralized RAN is where the BBUs are pooled, and the site only has the antennas and RRU. And in this case, it was introduced in the CRAN, the option to split further the baseband unit. So the remote radio unit is at the site, at the near the antenna, and then the baseband unit is pulled somewhere else in a centralized location. And the functions of the BBU can be performed by two different components, the distributed unit and centralized unit. Okay, and then next is BBU functions are virtualized and run on commercial off-the-shelf server, no, which made it somehow open. But in Open RAN, the RRU, BBU, and the FH or the front haul interface connecting the RRU and BBU are all open. Then later we'll see the functional split wherein it describes what are the functions, what are the protocols that lie on the distributed unit and the centralized unit. Okay, so this is another summary of the RAN architecture evolution, looking at it from the point of view or from the perspective of the different RAN components. You'll see here we have the remote radio unit, the baseband unit hardware, and the baseband unit software, and the front haul interface connecting RRU and BBU. Okay, so you can see in traditional RAN or the DRAN, it's all of this are proprietary, and then in centralized RAN, everything is still proprietary, but the BBU is pooled, and somehow it's going to be it was towards the transition towards the open. And then virtualized RAN, a lot of the components are still proprietary, and but the hardware is commercial off-the-shelf server. The software is virtualized, so it's a virtual network function running on the COT server. Then in Open RAN, everything is open, although the software can still be proprietary, but there are efforts now done by the ORAN Alliance to also have the open source software standardization of also the software components. Okay, so you can see the RRU is also commercial off the shelf. It's a software-defined radio. The hardware of the BBU is a server, COT server, and the front haul interface is open. So later we'll look into the different front haul interfaces, the open front haul interfaces that can be used to realize the Open RAN. Okay, so the main idea of Open RAN is to have the following. It has a virtualization. We virtualize the network functions of the BBU. It should have this functional split to allow mobile network operators on how they plan to deploy their functions. So are all the ADC, the modulation, the error coding done on the BBU or the RRU. And then the Open RAN fosters open source, open standard, and eventually interoperability between different vendor devices. Okay, and here is also a review of the RRU and BBU with respect to the OSI model. It can have basically the RRU to have the RF functions, the radio frequency functions, while the BBU to have all of this above, the higher physical layer and the MAC, the RLC, the PDCP, and RRC. So in the OSI layer, we know there are seven different layers. We have the physical, data link, network, transport, session, presentation, application. But for radio access network, the focus is only up to layer 3. So the data coming from the upper layers is not looked into. So, but basically, the purpose is to transport it, towards the end user. Okay, so the RAN protocols under each part are listed here. I think, no, sorry. So the details of this were discussed in the last meeting, but each part has certain functionalities. So we have the radio frequency, the PHY layer, the medium access control, radio link control, packet data convergence protocol, RRC, SDAP. Okay, so which of these RAN protocols are uh, are in the distributed unit or centralized unit? We'll know more about that in the functional split. Okay, so also this is a review of the ORAN Alliance architecture. So this is the main slide of the deep dive into ORAN architecture. This is where we can see all the functional components of the architecture, the blocks, and also the interfaces. Okay, so you can see here the SMO, the Service Management Framework, the one at the top, orchestrating everything, orchestrating and providing the housing the non-real-time RAN intelligent controller. So this is where most of the tasks that are greater than 1 second of latency are being performed. For example, modeling of training the models for AI applicable to the radio access network and things like that. So we'll go over that briefly. And then we have the near real-time RIC. From the name itself, it's near real-time. It houses the task for less than 1 second, of the latency. So usually this is for optimization of the radio access network, of the radio functions of the node. Okay, and this SMO actually can connect to several different nodes. Can connect to an eNode B, an Open RAN eNode B. So this is a 4G RAN. Okay, but originally Open RAN was proposed for 5G, but there are efforts to also deploy it for 4G, so that it is the 4G implementations are also open. Okay, so this SMO coordinates also the other nodes, and then also the other nodes. This is one node basically, this part here. Okay, what else? The near real-time RRIC is connected to the centralized unit, to the distributed unit. Okay, so you can see it's connected via the E2 interface. Other nodes can be connected, are connected as well to the near real-time RIC, and also connected to of course, the SMO towards the A1 interface. Okay, so the centralized unit here, the CU, here it's just represented as CP because there's a control plane and a user plane. But if you see CU, it means centralized unit. And if you see the O, that just means open or ORAN. So it's an ORAN centralized unit. So it is following the specifications of the ORAN Alliance. Okay, so between the control plane and the user plane, you have E1 interface. And towards the distributed unit, there is an F1 interface. This is the mid-haul interface. The mid-haul interface connects the centralized unit and the distributed unit. And also the distributed unit is connected to the radio unit via the open front haul interface. Okay, so you can see here there is a legend for the different interfaces because it depends on who is managing or who proposed the interface specifications. So most of the green ones are from ORAN Alliance. And the gray ones here, the F1, the E1, are from 3GPP. Okay, so this is the ORAN architecture. Okay, and also there is this ORAN Alliance reference architecture. This architecture can also be related to the previous slide because you can still see the SMO, the non-real-time RIC, the near real-time RIC, the control unit, the distributed unit, no? And or rather, this one should be a centralized unit, no? The distributed unit and the radio unit. No? It's just a little bit different, no, in the drawing, the diagram, but as you can see, the colors are quite similar, no? So that it's consistent, no, to what you have seen. Okay, so in the if you search for ORAN Alliance Reference Architecture, actually you'll see a lot more detail into that. Under the SMO, there are several details like what it is for, what kind of apps it contains. Then still we have the non-real-time RAN intelligent controller there. And then this SMO connects to the RAN components through the A1 interface. And this A1 interface, no, is connected to the RIC. So it's the termination, no, is at the RIC. And then inside the near real-time RAN intelligent controller, there are different apps. We'll go over this in more detail later. And then we have the E2 interface connecting the RIC to the DU and the CU. Okay. So this RIC, this near real-time RIC manages, controls, optimizes the DU and the CU. Okay, and then also you can see here this particular multi-RAT centralized unit protocol stack. It just means that you can have multiple radio access technologies. You can have 5G, you can have 4G. All of them can be connected to the near real-time RAN intelligent controller. Okay, so the two important interfaces here for RAN intelligent controller are A1 and E2. A1 is the one that is connected northbound between the two RIC, and then the E2 interface connects to the RAN components from the basically from the near real-time RIC towards the RAN components. So just a brief recap, no, just short activity, you know. So in your chat box, no, please type the answer to the following. Let me name one by one. No? So this is the ORAN architecture, and you can see there are blocks that are not not named; they're just numbered. No, so in the chat box, no, please type what is the block under number 1. What is this color blue here? The one that you can see with my mouse. Ano pong name niyan? What is the name of that block, that component? Ay, mabilis. Yeah, amazing. So it's non-RT RIC or non-real-time RIC. No? So yung mga medyo matagalan na task, no? This is where it is housed. And it is where like the overview, no? Overview of the whole framework. How about number 2? What is number 2? Ready to press na kagad, kakasabi ko pa lang na may sagot na. So it's a near real-time RIC. No? So medyo competitive tayo ngayong umaga. Yung nga lang, wala tayong prize. Unless si Richard offers a prize. I don't know. Okay, next, what about number 3? Okay, may sagot. Naka-ready na talaga, naka-type na siya. So it's ORAN, Centralized Unit Control Plane. And number 4, what is number 4? Okay, so ano po yung number 4? No? Isa pala yung nagta-type. It's ORAN. Teka, dapat meron, ayun pala, meron pala akong answer key dito. Okay, OCUUP or ORAN Centralized Unit User Plane. Number 5, what is number 5? Okay, ODU, no? ORAN Distributed Unit, no? ODU. Then, finally, number 6. Yan, okay. Yan, so yung mga iba't ibang components na yan is like from the general no overview papunta dun sa RAN hanggang sa end user. No? So hindi ko na na blanco pala yung iba, no? But of course you can see there is an eNode B here, a cloud. This cloud is helping the SMO to parang ma-process niya lahat ng information if there are data that is found on the cloud, no, on the data centers, no. Yan. Okay, so later in the next few slides, meron tayo ulit activities. So, try nyo to remember na yung mga concepts, no. Wala namang grade yan, so don't worry kahit magkamali or hindi nyo agad na sundan, it's fine, no? It's part of the learning process. Okay, so this particular section, no, is now the RAN Intelligent Controller overview and the functional split, no. We are already familiar that there are components in ORAN, no, that pertain to the RIC, may non-real-time saka near real-time tayo. Yan. Okay, so before going into the details of the different RICs, no, let's first understand, no, how they came about, no, who is managing what, no, in the ORAN Alliance. So in ORAN Alliance, just like other organizations, they have groups or working groups, task groups that manages or studies, prepares the specifications for different components. Just like in, for example, IEEE, for example, in 802.11 series of family, there are different working groups at each version, 802.11a, B, etc. The same with ORAN architecture or ORAN alliance. There are various working groups. Not all the groups so will be mentioned here, but just the ones that are related to our topic. Okay, so the working group 1 is focused on use cases and overall architecture. So the responsibility of this working group is more on identifying the task for the overall design of the ORAN architecture. So they are somehow the one that leads all the other working groups. Next is the WG2 or working group 2. They are tasked so to handle the non-real-time RIC and the A1 interface. So remember the A1 interface, it's the interface connecting the two RICs. So balikan niyo ulit yung ORAN architecture to remember where this A1 is. Okay, the goal of this particular working group is to support non-real-time intelligent radio resource management, higher layer procedure optimization, policy optimization, and providing AI ML models to near real-time RIC. Okay, so sa name pa lang kasi non-real-time RIC, it is more on tasks that are not real-time, usually tasks that require more than 1 second of latency. Perhaps if you need to train a model to eventually apply it to the radio access network, you need time to process the model from all the data gathered. You train it based on machine learning, whatever model is applicable to that kind of data. So training, of course, of the machine learning model takes time. It's not a task that can be performed in 1 second. But once implemented, then it can be cascaded down to the near real-time RIC. Okay, so working group 3, this one is near real-time RIC and the E2 interfaces. So remember the E2 interface connects the near real-time RIC to the different nodes. So the E node B or the G node B. And inside the nodes, there are a distributed unit, the centralized unit. So the near real-time RIC are connected to those components so that it can optimize them. So it enable, or rather the goal of this working group, enable the control and optimization of the RAN components, the specific elements for particularly for radio resource management. So more on the operation of the radio access network. It can, of course, it needs to collect some data and then send out the commands for the radio access network to apply. Okay, so connected din po ang near real-time RIC sa taas kasi upon collecting the data, it will also forward it to the non-real-time RIC kasi that those data can be used for optimization and mga intelligent models. Working group 4 is the open front haul interface, and their goal is to provide specifications for the front hall interface para there is interoperability between multi-vendors. Again, when you say front hall, this is the interface connecting the distributed unit and the remote radio unit. So the front hall, the one that is nearest to the end user. And then the working group 5, open F1, W1, E1, X2, Xn interfaces. So other interfaces found in the architecture. So the purpose of their group is to provide the operations or the specifications for a fully operable multi-vendor network that is compliant with the 3GPP specifications. Ayan, so hindi lang yung 5, marami pa. But even not only 11 working groups, there are even research groups as well. But ito lang po yung cover natin for today. We have working group 6, more on the cloudification and orchestration. So to drive the decoupling of RAN software from hardware and to produce technology and a reference design for all parts of a RAN deployment, including C and DU. Although hindi na natin mako-cover karamihan dito. No? WG7 is white box hardware to specify and release complete open reference design to for supporting the coupled software and hardware. Stack reference design, software architecture, design release plan for the OCU DU based on ORAN 3GPP specifications, open X-Hall transport. It's now focused more on the transport network, whatever the equipment, the physical media, etc. Since although the goal, or rather the focus of Open RAN is yung radio access components, but you need the transport network to connect to the core network. So it should still be able to, there's still a connection to the transport, even if it's not really RAN. WG10 is operations and maintenance, or OAM. What are the requirements, architecture, and the O1 interface? And if you go back to the architecture, you'll see the O1 interface connects to several different components. And then finally, the WG11, security. So more on the security aspects of the ORAN. We also have a separate Asia Open RAN Academy course on this, that not part of this lecture or not part of this particular webinar. So what are the important working groups in our topic for today? That would be, the working groups 2 and 3. Because as you can see, it's about the RAN intelligent controllers, the non-real-time and the near real-time. And again, just a review again of the RAN intelligent controller. Over the different generations, there were some controllers before. And for example, in 2G, the controller is the BSC, or the base station controller. And it's found, of course, in the GSM Edge RAN. Then in 3G, we have the radio network controller, RNC, to help manage the node B. Okay, so both of these controllers were responsible for orchestration and management of the RAN. And by the time we start 4G, there was no separate controller elements. The purpose was to simplify the architecture and allow faster response times. But later, as we start to disaggregate the hardware and software, just like in virtualization, we can pull the virtualized software functions at a centralized area, which allows us to optimize the operations of the server. If you don't need to have a dedicated server just for one function, you can virtualize them in a COTS server. So mas efficient, basically yung pag-utilize ng server resources. And of course, it also assists in faster prototyping, faster provisioning of the resources. And in 5G, in 5G Open RAN, the RIC is the controller. It enables the eNode B and gNode B functionalities for network intelligence, resource assurance, and resource control. So notice the RIC is not only handling gNode B, but can also handle eNode B from basically the open eNode B. So the 4G nodes that were modified, or rather upgraded to be open. Okay, so the driving force of having this particular rig is the need for the 5G components or the 5G applications to have low latency. So the 5G applications are required to have low latency and require network function virtualization and software-defined networking to enable configuration optimization and control of the RAN infrastructure. And at the edge, RIC enables the functionalities at the nodes. And originally, it was defined for 5G Open RAN, um, um, but it is essential to support interoperability of different hardware and leverages data analytics and AI, since there can now be machine learning for optimization and intelligence. Um, in general, the purpose of the RIC is for self-optimization of the RAN and, of course, for efficiency purposes. We are already familiar with a non-RTRIC and near RTRIC, and we saw that the non-real-time RIC is located at the SMO part, at the SMO framework. It's mostly supporting the task requiring greater than 1 second of latency. And particularly, it is hosting the R apps. So later we'll go over into detail now what is R apps. But this is for RAN automation optimization, such as configuration management and data analytics. Near real-time RIC framework or near real-time RIC support tasks that require less than 1 second latency, and the tasks are also managed by the X apps for functionalities like radio resource management. Okay, so pag non-real-time RIC, nandun yung R apps. Pag near real-time RIC, nandun yung X apps. Okay, so this is also another way to look at the architecture, but focusing more on the non-real-time RIC architecture. This is an overview, but later in the later section, we'll go more in detail on the non-real-time RIC architecture. But again, as you can see, this is almost the same as the other diagram. Medyo naiba lang ng konting arrangement, pero yung kulay, it's still the same. We have the service management and orchestration, SMO. And under that framework, or in that framework, we have non-real-time RIC. And the non-real-time RIC is here, is connected to the near real-time RIC using the A1 interface. Again, the working group 2 is responsible for the non-RTRIC and A1 interface, kagaya nung na-discuss earlier. And then, again, the near real-time RIC, tapos ORAN network functions, hindi na pinahita, tapos the ORU. Okay, so the important interface for the non-real-time RIC are the A1 and the O1. Okay, so A1 interface and the O1 interface. Okay, this one now is the near real-time RIC architecture. Actually, there are more detail here. Ganon din doon sa kabila, no? But mamaya-maya pa natin sila titignan, no? Okay, so still we have SMO, non-real-time RIC. This one hosts the R apps. Then of course, the non-real-time RIC connects to the near real-time RIC. So the near real-time RIC hosts the APIs for the X apps. And then you can see the two are connected, or rather the non-real-time RIC is connected to the near real-time via the A1. There is, of course, going to be an A1 termination. And the near real-time RIC is also connected to the SMO via the O1 termination. Okay, so also the working group responsible for the near real-time RIC is the E2 interface. The E2 interface is the southbound interface na pababa. It's the one towards the E2 nodes. For example, the DU, the CU. Okay, so yung kanina, northbound interface itong dalawa, O1 and A1, kasi pa north, pataas. And the E2 interface is the southbound interface. It's the one going down, the architecture. So you'll have the E2 interface connected to the E2 nodes. Okay, so since we're halfway through the webinar, we can have a short break. No? Let me give you back to Richard. Richard, or andyan ka ba? Are you there?
Yes.
Ayan. Okay.
Okay, so
Pahinga
let me
muna.
just share my screen. Thank you, Josil. So bigyan lang muna natin ng time si Josil to have a water break. And while we are waiting for Josil to come back, let's have a practice through our Kahoot. Ito yung ating link and I will share it sa ating. So please join sa ating Kahoot. So ang ating pag-uusapan, ating quiz is all about RAN Intelligent Controller. So, meron dito mga parts na itatalakay or i-discuss ni Jocelyn after the break. But otherwise, let's take it sa quiz. Okay, and then for those who just come in right now, meron tayong attendance sa Asia, sa USA. So I encourage you to fill out this form para sa attendance lang ng USAID. So after this session, then magkakaroon pa tayo ng separate access or separate form for DICT para naman sa inyong mga CPD points. So if you are not able to join or you don't want to join the Kahoot, don't want to practice, you can just fill out the USAID attendance. Okay, I think we can start. And for those na gusto pang humabol, you can join the quiz or you can just type in your answer through the chat box. So let's start. Let's start, no? Okay. RAN Intelligent Controller. Question number 1. Multi-select. What are the available near real-time RIC services that you use over the E2 interfaces? Okay, so what are the available near real-time RIC services over the E2 interface? Meron tayong mga iba't ibang klase. The one that carries the outcome. And of course, there is a policy coming from the SMO, report, and then control, and then insert about the fields. Okay, so si Vern yung number 1. Okay, next question. Number 2. Can an X app send a control message directly to an E2 node? So we have the X app, and then there is this E2 node. So the question is, can an X app send a control message directly into an E2 node? A, no. B, no, not A. Triangle. Yes, no. X app has to send the message to the E2 termination point first, and then no. Conflict mitigation function near the real-time RIC. Okay, very good. Number 3. Which entities in the ORAN architecture can be called E2 nodes? So which of the following can call as the E2 node? ORU, OCUCP, OCUUP, OE node B, NDU, or the near real-time RIC? All right. So the correct answer is OCUCP, OCUUP, OE node B, and ODU. Next, number 4. Select which elements are part of the near real-time RIC? The X app management, the X app, the R app, A1 ML functions, A1 policy function. Okay, the X app management, the X app, and the conflict mitigation function. All right, next, number 5. Select the correct sentences. Which sentences are correct? Near real-time RIC operates in the management plane. The non-real-time RIC operates in the RAN domain. The near real-time RIC operates in the RAN domain. Or the E2 node is part of the RAN domain. The non-real-time RIC is part of the SMO. All right, so near real-time RIC operates in the RAN domain, where the SMO is on the management plane. E2 node is part of the RAN domain, and non-real-time RIC is part of the SMO. Number 6. In non-real-time RIC framework, when an R app does not have access to subscribe parameters that are provided by the other apps, what happens? For example, your non-real-time framework R app does not have access. One of your R app moves the access the subscribe parameter. What will happen? It will work anyway and produces regular output without taking the necessary in. Number 7, support non-real-time RIC. It supports non-real-time RIC intelligent control, radio resource management, procedure optimization, and run policy, which is following supports non-real-time RIC, non-real-time intelligent radio resource management, higher layer procedure. So this is the non-real-time RIC. Number 8, what is the minimum reporting period of performance management over the E2 nodes? Have a reporting period, right? Over the E2. What is the minimum reporting period? It's 10 milliseconds. Number 8 or number 9. Can an E2 node function independently in their real-time RIC? Can E2 nodes function independently on near real-time? Yes or no? Yes, because the near real-time RIC only adds intelligence to the E2 nodes. Number 10, it gives a control in the system, the time scale used for traditional mobile network management in minutes per hours. Which one gives a control in the system for traditional mobile network management? It's the non-real-time RIC. Okay. If it's more than 1 second, right? It's a non-real-time RIC. Okay. Number 11. Select the correct sentence or sentence. XApp can be part of either near real-time RIC or non-real-time RIC. XApp is part of a non-real-time RIC and RApp is part of near real-time RIC. RApp is part of near real-time. XApp is part of near real-time. Following sentences. Right. Yes, of course, RApp is part of the non-real-time RIC and XApp is part of the near real-time RIC. Okay, so last question. Before I turn you back to Jocelyn, what is an enrichment information? What is an EI or enrichment information? With an additional. Actually, this is an additional site information, like for example, site details, coordinates, right? KPIs that or site data from external source to add information in the A1 policy that they can use in the machine learning. All right, so let's see who's in the top 3. So top 3 is RCC, top 2 is Sander, and top 1 is DICT. Congratulations to top 3 for our ORAN Intelligent Controller quiz. So you have earned a bragging rights again. All right, so thank you very much for all who participated, and I'll hand over you to Jocelyn for the next discussion.